Assalamualaikum students, hope you all are and doing well, and I do hope that you already have done the assignment that was given to you in the week 1. So here we are on week 2, so let's recap the lecture that was of week 1. So we were talking about what is science. In what is science, we just talked about science, what science is. Science is systematic study of the things and the nature and the environment and how it affects us, right? Then we talked about the different branches of science, and lately we talked about, lastly we talked about how science limit us in predicting the events or in preventing the events that are like natural disasters, right? But the chapter didn't end here, students. So we have the topic today. We are going to discuss the scientific method. So what scientific method is, we are going to define that. Then we will invest some stages of scientific method, because it's a method, so it has different stages to go through to develop a scientific method. So we'll define that stages. Then we will define what is observation and hypothesis, and lastly we will define theory and law, how theory is different from law. Okay, so about scientific method. So what is scientific method? So basically I was talking about there are some stages of scientific method, right? So the first stage of scientific method is basically observation. So observation is the stage which is coming first when we are talking about scientific method. So we have to record our observation, and how we can record our observation, we can see, we can think, we can take notes of, right? We have to observe keenly and carefully, and we have to take accurate measurement. If we can't take accurate measurement, it means our observation is going to be vain. After observation, the second step come in. The second step is making hypothesis. So basically what hypothesis is, hypothesis is basically, you can say, a suggestive statement. It's just a statement, nothing else. It's a statement, and that statement should be meaningful. Okay, it's a meaningful statement, and that is based on obviously observation. You observe something and you make an hypothesis, and you make an statement that's going to be presented. Okay, for then to prove that statement right or wrong, you are going to do experiment. Okay, and after experiment, if that experiment proves right, means the result are positive. You were saying, for example, you were saying that malaria is caused by mosquito, and you know that you observe it, like a person had a bite of mosquito and he developed malaria. It's your observation, and you make a statement that malaria is caused by mosquito. That is your hypothesis. Now you have to experiment. You take that person's blood, to take the samples. You can compare that sample with the mosquito's blood, and you can give an idea about, like, yes, this material is found in mosquito and found in the blood of the human that has malaria. So your experiment is correct. So if your experiment is correct, it becomes theory. Okay, but if experiment is not correct, that doesn't going to support your result, your hypothesis is going to be rejected, and you have to do your hypothesis again. Okay, you have to come up with a new statement again. Okay, got it? Right. And if your experiment is right and you made it become theory, this is going to be not the last experiment. You have to do hundreds of experiments to make your theory become law. So law is something that is always appear to be true. So if your hundreds of experiments are going to be proved right, your theory becomes law, and it means that yes, whenever we talk about malaria, you are right about it. Mosquito cause malaria. Okay, let's take another example. So basically your observation is shadows are cast when object block light. You can experience this at your home. Just block the light and you can make shadows of your hand, right, of yourself as well. So this is our observation. And what is our hypothesis? We are saying that maybe light travels in a straight line. That's why that's why when we block the light, shadow forms. Okay. Now, what is the next step? Yes, the third step is experiment. So we are going to do experiment. Okay. what we are going to do, we just put some blocks of cardboard and make tiny little holes in them, and we make them straight. At one side we just turn on bulb, and other side we are going to see from there. Okay, and you can see light is traveling straight to your eyes. Okay, but next we can do, we just displace B from the original position, and as we displace B from the original position, light got blocked and we can't see any light coming from the block C, because light is going to be blocked by this B cardboard. Okay, so we found out that light travels in the straight line. So yep, our experiment proved it right? So it became theory. Now what we need to do, we have to test number of times to found it to be true. We test this experiment at one place and other place and another place with this cardboard, with another type of cardboard, and when this is going to be proved 100 times or million times true, this become a law. Okay, so this is the scientific method. What are the steps in the scientific method? First you observe, right? So observation. Secondly, you make an hypothesis with a meaningful statement based on that observation. Thirdly, you do experiment. You'll plan experiment to make your hypothesis true. Okay, and thirdly, fourthly, your experiment became true and it became a theory. And fourthly, you have to repeat those experiments and to make it a loop. Okay, so this is all about scientific method. So after scientific method, to develop that scientific method, the scientific process, we require some skills. Okay, because in scientific method we are going to develop some experiments to make it true, to make it theory, and then we are going to do the experiments again and again, right, to make it a law. So during those experiments we should have, during that developing scientific method, we should have required some skills. Okay, so what kind of skill we are going to require? We are going to list down those basic skills, then we'll define interference and what is the importance of positive attitude in study of science. You can found out this topic in your book page number 5 and 6. Okay, so basically the first skill that is required is observing carefully and accurately. If you can't carefully, and you are not going to measure accurately. If you can't measure accurately, your all data is going to be vain, the wastage. Okay, the wastage of your time as well, because when you are going to experiment with the wrong data, it means you are going to produce wrong results. Okay, so can't do observation uncarefully. You have to be very careful when you are going to observe something. And what skills you need for observe? Yep, you can involve your 5 senses. What sight? You can see something, you can smell, or right, I smell that thing and this has a smell like this, right, and this thing also have smell like this. So yep, we are talking about the same thing, for example, right? Hearing, we hear, for example, there is thunderstorm and you are inside your room, but you can hear that voice of the thunderstorm and you can communicate with your other friend that yeah, there is thunderstorm outside because I can hear it, right? Similarly, you can taste, you can touch, to gather all information about, right? Secondly, when you observe accurately, you measure something, observe carefully, you have to communicate effectively, because in developing a scientific method, you are not alone there. You have to convey your message, you have to be very vigilant and careful with others as well. Okay, so when communicating, you have to communicate the exact data you have collected. So you can make tables, you can make charts, you can make graphs, you can correctly jot down the data, you can make label diagrams. So right, like if you see something, you just make your, if you are a good painter, you can just make the diagrams, right? Thirdly, when you are, first you observe, you communicate effectively, now you are going to make a hypothesis, right? Uh, but before hypothesis, you just make a statement that is known as inference. Okay, inference is a statement that we arrived on by reasoning based on our observation of environment. For example, I told you about that malaria thing, right? So mosquito cause malaria. This is my statement, that is inference. And if it, I'll communicate with other ones and I'll show them my data that I collected, and if they're, my data is worth taking, the other will say yes, okay, your statement can be tested, and then that statement become hypothesis. So in inference, what skills we involve, we have to think, right? What kind of statement I have to make, what kind of statement I had to make, I have to think very carefully, because the statement should be reasoning based, should be a meaningful statement. And secondly, we have to discuss for the explanation and for the observation with others. So again, you have to communicate effectively with your other fellows. Then we have to plan experiments to test, right? So that include what kind of apparatus we are going to use, because we are going to do experiments, and in experiment we are going to use some apparatus or chemicals which we are going to use. For example, the blood, we can't take blood in our hands, we have to use some kind of laboratory apparatus like petri dish or other plates, right? How we are going to put them together, and about the fair test and validity of hypothesis. You can't have negative test and you can say, oh my god, my tests were positive and these reports were fake. No, you can't say that, okay? And fifth, the most important thing is your attitude should be positive, okay? Because you are going to be a scientist, you, my little tiny scientist, right? So your attitude should be positive, right? So negative people are like blindfolded people, they can't see positivity in anything, but positive people can see anything, they are curious about the things, right? What thing can they adopt, what thing can they not adopt, they are impartial, they do fair things, right? So fair, and they have healthy skepticism and healthy criticism. So whenever they feel criticism, criticized about the things, they take it positively and they improve on it, okay? Not just make it like, okay, I'm not going to do it again because they are criticizing me, okay? You can't do like this. And you should be open-minded, because there are going to be many things in your life, and you should be open-minded if you are going to be a scientist, okay? So these are some things that you have to be in your mind, have to take in your mind, because you are going to be science, you are going to be future scientist, right? Okay. So this is all about we have to discuss, okay, for lecture number 1 and lecture number 2, and obviously we have some homework assignment for you. Okay, let me show you your homework assignment for this lecture. Okay, so here's your homework assignment. You have to do review question number 3. You have to draw the flow chart to show the stages and the scientific method of investigation, and you have to differentiate between theory and law. And we already discussed about it. Okay, for differentiation, just make a line in between and differentiate it. Secondly, you have review question number 4. List the process and skill which are required to study science. You have to define interference and what positive attitudes I need to adopt to study science. So you have to write the bullet points, and best of luck for your homework. I'll see you in the next lecture. I hope you'll do your homework soon, and best of luck. Stay safe. Allah Hafiz.